That happens in the network layer. And what is the factor who affects whether the fragmentation is going to happen or not?
MTU, sir.
MTU. Okay, that is called as maximum transmission unit. Can anybody tell me literally what is the meaning of MTU? If I say the MTU is 1500 bytes, what is the meaning of it? Very so key. So maximum size of the datagram. You can't say anything like, because most of some of the time when I ask, sorry, when I go and ask the students what is this MTU, they say maximum size of the packet. Koi bolta hai maximum size of the segment. So that you should not be confused. It is the maximum size of the datagram. Exactly, you have to understand that. Okay. So if my datagram is exceeding, size of the datagram is exceeding 1500 bytes, so then in that case, so there is a data fragmentation. That we understood very clearly. Okay. So today let's look into how exactly this fragmentation is going to happen. So what are the various fields or information available in the header so to cope up with this particular fragmentation. Okay. Now if you remember in the last class, we talk about there is a complete row dedicated for the fragmentation, and out of it the first field is called as identification. Identification, which is represented in 16 bits. And so next, so 3 bits are called as flags bit. These are 3 bits, and the final 13 bits is for fragmentation offset. Fragmentation offset. Okay, so these are the 3 fields basically, so dedicated for the fragmentation and reassembly job. Okay, now let's start with the identification. What is the requirement of this field? Okay, so in order to understand that, let me draw once again the diagram what I draw in the last class. So this is the source machine connected to a router. This is how it is finally connected to the destination machine. Okay, now let's say I wants to, that is there is a process P1 running in source machine, okay, and is generating a message whose size is 2000 bytes. Okay, now so the MTU of the system is 1500 bytes. MTU of the system is 1500 bytes. Now I have a so datagram of 2000 bytes, and the size of the MTU of my device is 1500 bytes. So as I have already discussed, so it needs to be fragmented. That means it needs to fragment into 2. One is of 1500 bytes, another one is of 500 bytes. This is the first fragment, this is the second fragment. So 2 fragments has been generated, so out of the original datagram. Okay, so now the first fragment is going, so first fragment is going and following this path, let's say. Okay, so to deliver through this. Second fragment is going and so follow this path to deliver here. Okay, so wherever both the fragments has been delivered, F1 is delivered, F2 is delivered. Similarly, so let's say, so this process again generates another message of 2000 bytes. First message it has generated 2000 bytes. 2 fragment has been generated out of it and sent in the network to receiver, the receiver end. Similarly, another packet is generated with the same 2000 bytes, let's assume. So again, based on the fragmentation concept, again it is going to divide into 2 packets, 2 fragments. One is 1500 bytes, other one is 500 bytes. The first one is F1, F2, let's say. Similarly, F1 follows this. So F1 reaches here. So F2 follows this, and F2 also receives here. That means, so F2 fragments of 1 packet and 2 fragments of another packet, all the 4 fragments are received at the destination. Now, the next question is, whenever the destination is going to reassemble, so you have to look into which are the fragments belong to the same packet. So you have to identify, the receiver has to identify which are the fragments belong to the same packet. Now the question is how it can be done. So by looking into what information it could able to do the reassembly by looking into these are the fragments belong to that particular packet. This is where this identification field is going to help. That means, so if I look into, let's say this F1 and this F2 are belonging to the same packet. So that's why if I say, so this particular fragment has an identification value X, then these fragments also must have an identification value X. That means all the fragments belonging to the same datagram must have the same identification value. So at the receiver, so whenever it is going to do the reassembly process, by looking into that identification value, it could be able to decide exactly what are the fragments belong to the same datagram, so that I can take into account for finally reassembling and generating the original packet out of it. This is what is the purpose of identification field. Okay. So similarly, if I look into the other packet, so this fragment must have a different identification. Two identification cannot have the same. That means two packets, two segments, two different segments belonging to two different packets, so cannot have the same identification number. It has to be unique. So that's why in this packet, the fragment number 1, so if the fragmentation is Y, so here for this F2, so this will be Y. That means looking into this identification field, so destination can able to reassemble the packets correctly. That is the purpose of it. Okay, understood? Okay. Now, next is flag. So what is this flag? Let's try to understood. As I have already told, there are 3 flag bits. Okay, the first flag bit is basically used for future. So this is called as reserved. Till now we are not using this particular flag bit. Okay, so the second flag bit is called as a DF. Do not fragment. Do not fragment. Okay, what is the purpose? We'll talk about it. So third one is called as MF. That is more fragments. Okay, let's look into this more fragments first. What is the usability of it? Okay, if I look into here, see, so I have an original datagram of 2000 bytes. Now it has been divided into 2 fragments, 1500, 500. Okay, so that's why what happens in the first fragment, this MF bit will be set as 1. Because this is one flag bit, 1 bit. So either it can be 0 or it can be 1. So now the question is when it is going to 1, when it is going to 0. So if I say this is my first fragment, this is my second fragment, 2 fragments has been generated, okay, out of the original datagram. So the first fragment must have a MF value of 1. What does it signify? That is still more fragments to follow. This fragment is telling whenever receiver is going to receive this fragment, by receiving this fragment, it could be able to understood, no, this is not the last fragment. Okay, somehow it is either the first fragment or it is an intermediate fragment. It is not the last fragment. Still some more fragments to follow me. So that is what, so this MF bit is set to 1. But if I look into F2, F2 is my last fragment because 2 fragments has been generated and F2 is the last one. So that's why in this F2 fragment, my MF bit should be set to 0. Okay, so that's why when MF bit is set to 0, receiver receives it. By looking into it, it can able to easily understood. Okay, this is my last fragment. Okay, which is basically so helpful for the reassembly procedure at the receiver end. This MF bit is going to help for that purpose. Now the most important thing, let's try to understood what is the DF field. Okay, so that is the DF flag, do not fragment. What is the need of it? Okay, so now let's look into here what I have told. The packet has been fragmented into 2. One is 1500 bytes, one is 500 bytes. Okay, so now what happens when the packet receiver or fast fragment receiver, this router 1, this is router 1, this is router 2, this is router 3, this is router 4. So when it is going to receive at the router 1, let's say router 1 is having a capability of 1000 bytes. That means the NIC card capability is 1000 bytes. That is the MTU of the, so router 1 is 1000 bytes. But so what the sender has sent is segment of what? 1500 bytes. So now is it going to require further so to divide the packet or not? Or yes or no? Yes or no?
Yes.
So because if it does not, if it is not going to divide the packet, not going to fragment the packet, so then it cannot carry because its physical capability is 1000 bytes. Okay, so it can carry maximum 1000 bytes of data at a single point of time. Okay, it cannot carry more than that. So that's why what is going to happen? So as the packet size is 1500 bytes, again there is a need of fragmentation. That means the fragment 1 is again subdivided into 2 fragments. One is of 1000 bytes, another one is of 500 bytes. So that's why, so again fragmentation is going to happen at the router 1. So then again it is going to send to, so router 2, let's say router 2 having a NIC capability is 500. So in that case, whenever it is going to receive, so this fragment of size, so 1000 bytes again, so that fragment is going to again So fragmented into two. Okay, so that's why, so fragmentation may happen again and again. So during the traversal of a packet in the network, but so as far as fragmentation is concerned, fragmentation is very, very costly. Okay, fragmentation is a costly process. When I say costly, so is the money is involved? No, no, no. So there is no money involved. So what is involved here as far as cost is concerned? So cost in terms of processing time. Yes. Okay, so it takes a lot of time. So the actually fragmentation process is very, very complex, fragmentation and reassembly process. So that's why it takes a lot of time to carry out the task of so dividing again, so reassembling the things. So that's why, can we think of a solution so where we can avoid this kind of so fragmentation are the intermediate routers? So before trying to understand that, let's try to understand where the fragmentation is going to happen. Can anybody think of where the fragmentation is going to happen? Now the first question, can the fragmentation happen at the source end? Yes or no? Is there a chance fragmentation is going to happen at the originating source end? Yes or no?
Yes, sir.
Yes, yes, yes. So that means originating source. Whoever originate the packet, so there is a chance fragmentation may happen because size of the packet may maybe more than the NIC card capability, that is the MTU. Similarly, now the next question comes. So whether there is a chance of fragmentation at the intermediate router end? Yes, because we have just shown it. Okay, so that means there is a chance of so fragmentation may happen at the originating source and also at the intermediate routers. Now, as I have already told, so this is a very costly process. Can we think of a process where I can go and so avoid this? What is the bottleneck MTU of the path? Are yes or no? Bottleneck MTU of the path. Okay, so if I know beforehand what is the bottleneck MTU of the path, let's say we understood right now. So router 1 capability is NIC card capability, MTU capability is 1000. Router 2 MTU size is 500 and router 3 MTU is 1000 bytes. So now we understood the bottleneck MTU in this path. So as far as communication is concerned is 500. If it is, so from the beginning, so whenever I am going to do the fragmentation at the originating end, so I will divide the 2000 byte packet into 4 fragments of 500 each. If I do that, so only one time fragmentation I have to carry out at the originating source end. No fragmentation is going to happen at R1, R2, R3. All the fragments is going to go smoothly to reach at the destination, where destination can reassemble all these fragments. Okay, so how it is possible? So for that purpose, we have to find out the bottleneck MTU of the path. Then only it is possible to go and do the fragmentation only at the originating source. So this goes and saves time as far as processing time is concerned. So thereby improving the bandwidth of the communication or the utilization of the channel as far as the computer network is concerned. Getting my point? So that's why now the question is how to do it. How to know? So what is about how to find out the bottleneck MTU of the path? So that is where my DF flag is going to help. This DF flag, that is do not fragment flag, is going to help me to know what is the bottleneck MTU of the path. Let's see how it is going to help me. Okay, now what is going to happen? So whenever this originating source is going to know what is the bottleneck MTU of the path, what he is going to do? He is going to send a dummy packet. To the network, he is going to initially send a dummy packet with a very large size packet. Okay, so now when it is going to send to the router 1 with a DF flag set as 1, what he is going to do? So he is going to send a packet with the DF flag is set as 1. That means do not fragment flag set as 1. Whenever router 1 receives this packet and he sees that its size is more than 1000 bytes, but my MTU capability is 1000. I cannot carry your packet. And whenever it sees into the DF flag, it is saying, please don't touch my packet. DF is 1 means it is giving an instruction, strict instruction. You can't please touch my packet. You can't divide my packet. If you want to send my packet, please send my packet as it is. So that's why in that case, what is the choice available at the router end? He cannot forward the packet. So then what he needs to do? He needs to inform the originator. Because we have already told, so there is something called error reporting. So that is a functionality of network layer. So by using the error reporting functionality, router 1 is going to inform the originator. So that is please, I cannot carry your packet. I'm not able to carry your packet because my capability is 1000 bytes. So indirectly, now the source knows what is the capability of router 1 or not. Very cleverly, so the originator knows, so what is the capability of this particular router R1, that is 1000. Then what is going to do? So once he knows that, now he's going to send a packet with 1000 bytes. With same DF flag is set as 1. वही DF flag को 1 set करके, so now what he is going to do again? So next time he is going to send a packet, dummy packet with 1000 bytes, size of 1000 bytes, setting DF as 1. So then now the fragment is going to go to router 1. So it is going to pass because its size is 1000, going to pass. So now router 1 is going to forward it to router 2. Whenever it reaches a router 2, again the same thing is going to happen. Its capability is 500. Its size is 1000 and DF is set as 1. So what is going to happen? So R2 is going to again so do a error reporting to the originator, saying that so I don't have a capability, my capability is this much. So indirectly now the source knows the capability of R2 like this. So the whole process goes on. So to know what is the bottleneck MTU of the path, so till reaching a destination. Are you getting my point? So that's why once originator knows that so bottleneck MTU of this path is 500 bytes. So what immediately is going to do? So next time onwards, so whatever original, I mean packets is going to send, he is going to divide with respect to so the bottleneck bandwidth, not bandwidth, bottleneck NIC card capability, that is bottleneck MTU rather than the MTU of its own. So that's why no further fragmentation is going to happen at the intermediate router, thereby saving lot of time and saving the bandwidth as far as the so network communication is concerned. So this is where the DF flag is going to help to improve. So whenever I say this is my original packet, this original packet has a size of 2000 bytes. जो example मैंने दिया था. Okay. So now based on the MTU capability, I have divided into two. One is of 1500. Other one is of 500 bytes. Okay. So what is the need of this fragmentation offset? Try to understand. Okay. So whenever this is fragment 1, this is fragment 2. Whenever it is receiving at the receiver end, it may happen fragment 2 will be received first and fragment 1 is going to receive next. There is a possibility. You can't guarantee that मैं fragment 1 को पहले send कर रहा हूँ, मतलब fragment 1 is going to receive at the receiver end always fast. There is no guarantee such like that. Okay. So because every fragment may follow also different routes. So that's why, so if मान के चलिए, so fragment 2 is received first, fragment 1 is received next. So then how, so the receiver will be able to know this is the second fragment, this is the first fragment. For that sake, he has to know what is the offset of this fragment. So the first fragment offset in this case will be 0. Okay. So the offset for the first fragment, offset means it is the position in the original packet. What is the position of so the fragment in the original packet? That is so what is offset, and it is going to help the receiver to actually rearrange the packet in the correct order so that it can so populate the original packet. So that's why, so if you look into the fragmentation offset for the first fragment, the fragmentation offset will be 0. Now based on that, so what is the last offset? If I look into this 2000, it is starting at 0, it will be 1999. So now if I ask you what is the fragmentation offset of the second fragment, can anybody tell me? 1500. Try to understand this. Okay. So that's why if I will provide information along with my fragment, that is when fragment 2 is received, वहां पर तो नंबर नहीं लिखा होगा ना, अभी मैं समझा रहा हूं आपको, लिख रहा हूं fragment 2, वहां पर थोड़ी लिखा होगा ये fragment 2 क्या नहीं ना. So that's why, so now it is going to return the fragmentation offset here is 1500 and the fragmentation offset here is 0. So by looking into this, the receiver can understand, oh, इसका fragmentation offset 0 means this is the first packet, this is the first fragment, this is the so second fragment. By looking into the size of the fragment, he can able to calculate what should be the fragmentation offset of the next one. So by looking into this, he can able to know second fragment का fragment offset 1500 होने चाहिए. So that's why from that now it is going to look into the packet with the so 1500 offset value so that he can go and get the second fragment to so assemble the packet at the receiving end. So this is what the usability of fragmentation offset. Fragmentation offset helps the receiver so to go and rearrange the packet Okay, at the receiving end in the proper order. Okay, so that is the usability of it. But now, so go to the next part of it. So what I say, fragmentation offset is represented in how many bits? 13 bits. Yes. So if it is represented in 13 bits, what is the highest value I can represent with this? 2 to the power 13 minus 1. Yes. This is the highest fragmentation offset I can go and present. Okay. But if I look into what could be the maximum datagram size, लेके जाता हूं 2 to the power 16 minus 1. In worst case, what may be the possibility? It may happen the first fragment is of 2 to the power 16 minus 2. First fragment का offset कितना बन गया? 0. Second fragment का offset कितना हुआ? What will be the second fragment offset? 2 to the power 16 minus 2. Roughly, approximately, if I tell minus 1 करके छोड़ देते तो. Okay, so 2 to the power 13 is the maximum possible so fragmentation offset, whereas in reality we may need to have a fragmentation offset of 2 to the power 16. Then how it is going to happen? कैसे fit कर रहे थे? 60 by 15. 60 by 15. That means whatever is the actual header length, I have to divide it by a factor of 4 so as to get logical header length. Okay. So this is what we are doing in case of header length. Similarly, here in this case, what I have to do? The actual possible offset is 2 to the power 16. But मेरे पास क्या highest available है? 2 to the power 13. If I go and divide, what I got? 2 to the power 3, that is 8. That means I have to divide the actual offset value with 8 to get the logical offset value. Getting my point? Are you getting my point? Okay. So if my actual offset value is 2 to the power 16, what will be the logical offset value? 2 to the power 13, because I have to divide it by 8. So similarly, can anybody tell me if my actual offset value is 8,000, what will be my logic is what the offset value I have to put in the fragmentation offset. I cannot put the real offset value because of this restriction. So I have to put a logical offset value. How the logical offset value will be derived? Original offset value divides by 8. So whatever value got, so that becomes my logical offset value. And that's why the offset has to be always a multiple of 4. Sorry, multiple of 8. Okay. So the way we have already told, always the header length should be a multiple of 4. Similarly, the offset value must be always a multiple of 8. This must be a datagram of 1500 bytes. I have a datagram of 1500 bytes. Now, the MTU of the NIC card is 296 bytes. Okay, and assume the network layer header is of 20 bytes. Based on this requirement, I have to calculate how many fragments is going to be prepared to send the whole data. So the first question is that. Second is that, so the detail about all the fragment. What is the detail means? All the header information I have to populate, or I have to discuss, or I have to find out in each and every fragment, detail of each fragment. Okay. Now, so first one more concept we have to apply here. So whenever we are going to do the fragmentation, so understood that. So what is there in the datagram? In the datagram, so there will be a payload part and the header part. Okay. So first of all, so from the datagram, you take away the header part, because you are never going to fragment the header, because every fragment is going to keep the same header so as to communicate to the final destination, same destination. So that's why we cannot divide the header part. So we have to first of all take the header part out of the datagram. So if I go and do that, my datagram size is 1500 bytes. So what will be the payload size now? Tell me. The header is 20 bytes given here. So that's why now my payload size becomes 1480 bytes. Now, similarly, my MTU is 296 bytes. So MTU is 296 bytes means what is the size of payload in the MTU? So maximum payload I can have inside the MTU telling means it is the payload plus the header. So header is 20 bytes. I have to take it out. So each fragment so can have a size of 2 to the power 76 bytes of payload. But मेरे पास कितना बाइट का पेलोड है? 1480 बाइट का पेलोड है. Based on that, I have to go on, so find out how many fragments. But before that, one more concept. क्या बोला था अभी? So each, so मतलब fragment offset has to be a multiple of 8. So let's look into that. If I am going to put 276 here, okay, so how many fragments? So मान के चलिए some fragments I have to prepare. Some fragments, I don't know how many fragments. Okay, but each का size, each fragment का जो so payload होगा कितना बाइट का होगा? 276. This is 276. This is 276. 276 dotted. So if it is, can anybody tell me what is the so offset as a fraction? I cannot keep a offset as a fraction. It has to be whole number. So that's why 276 is not divisible by 8. So if I go and divide it by 8, so I think quotient is going to come to 34. Yes. So now even if my capability is 272, so but I have to go by 276. So I have to go by 272 to so make my offset as a multiple of 8. So that's why now based on that I have to find out what is the number of so fragments. So what is the total size of mine as far as payload is concerned? So 1480. What is the payload of one fragment? 272. So if I divide, it is going to tell me how many fragments is going to prepare. So if I go and divide, I think its quotient is going to come as 5. So 5 means 1360. Okay. So what you understood right now, my payload, available payload at my end is 1480. Each of my fragment will carry a payload of 272. Very nice. So that means 5 fragments of full capacity and the last fragment of so payload size 120. So in total, there is a first question. So how many fragments? The answer comes to 5 plus 1. 5 full fragments and the last one is a so fragment of so size of payload 120 bytes. Okay, 6 fragment ban gaya. So now let's go for one by one. So what are the details to be filled up for the each and every fragment? So let's go for, this is fragment 1. Fragment 1. So क्या क्या information each fragment में जाना चाहिए? Identification. First one is the identification. Can anybody tell me what will be the identification value? It is random. Okay. So but that has to be same for all the fragments. So let's say I assume it is X. You cannot say that. Okay, that is going to randomly generated at the time of so generating these fragments by the system itself. Okay, by the network layer functionality is going to so prepared. Identification value ho gaya. Now, so next is flag bit. MF. Can anybody tell me what should be the value of the MF field here? It will be 1. Next is the fragmentation offset. Fragmentation offset. Anybody please, what is the fragmentation offset? So explain you. Now, अभी हिसाब से मेरा 6 फ्रैगमेंट बन रहा है. So 1, 2, 3, 4, 5, 6. Okay. And the first fragment is of 272 payload, 272 payload, 272 payload, 272 payload, 272 payload, and last payload is 120. Yes? यही तो ना? 6 fragments. Now,
yes, sir.
Based on that, you tell me पहला जो fragment जाएगा. So what is the so size of the datagram is 292 bytes. That means 272 as the payload, and so the 20 bytes of header is going to added as a part of it. So whole datagram says of the first fragment is 292 bytes. Very nice. So now go to the so offset is 0. Okay. Now go to the second fragment. Fragment 2. Okay. Actual one is 272, but we cannot put the actual one because of that restriction of 13 bits now. So we have to go and divide it by 8. So that is 34. So my second offset is 34. So that's why fragmentation offset is 34. Very similarly, so datagram size is 292 again. Nothing. Now similarly, fragment 3 के बारे में बोलिए. Identification क्या होना चाहिए? X. MF value क्या होना चाहिए? 192. So then fragment 5 के बारे में बोलिए. Same X, MF is 1. This is 136.
6.
This is 136. Then it is 292. Then fragment number 6. X is 272 bytes again. So the last but one fragment. So it is 170. So then what about the payload? I mean datagram size. This is my source machine. This is the router. The same picture I'm used to do. This is my destination. Okay. Now the question is, I already told about there is a need of fragmentation, there is a need of reassembly. Now the question we have already answered. So that is fragmentation is going to happen. Fragmentation may happen at the originating source end, or it may happen at the intermediate router end. Intermediate router end. So समझ गए ना? So now the next question is concerned reassembly. As far as reassembly is concerned, now if I look into, yes, reassembly has to happen at the final destination. Now the question, can it happen? Is it required to reassemble the packets at the intermediate router end? Answer is no. Why? Because two reasons. Because there are two reasons. The first and foremost important reason. So let's think of. So now I have divided one packet into fragment 1, another fragment 2. So fragment 1 may follow this path. Fragment 2 may follow this path. So this is fragment 1 follow, this is fragment 2 follow. If I want to reassemble, the reassembly does not happen at the router ends. Why? Because so there is a possibility that all the fragments may not be available at the router. That is the first. So not available. All the fragments may not be available. May not be available at the router. May available, may not be. If fragments are not available, how I can reassemble? I cannot reassemble. So that's why reassemble doesn't happen at the router end. This is the first point. Second point, even if all the fragments is, so let's say fragment 1 follow this path, fragment 2 also follow this path. So all the fragments is available at this router. But if I do this, let's try to understand what is the advantage, what is the disadvantage. अगर मान के चलिए इसका कैपेबिलिटी क्या था, so let's say 1000. Okay. Now इसका कैपेबिलिटी क्या था, let's say so 1000. इसका कैपेबिलिटी क्या है, let's say 500. कुछ भी ले जाइए. Okay. So now my packet, original packet size, this one is 1000. दो fragment का size 1000 मान के चलिए. Now whenever it reaches at this 2 fragments of 1000 each. Now, so what he is going to do, if he is going to reassemble these 2 packets, so now they again forms a packet of size 2000. Again, whenever it is going to, so try to send it to the other end, as its capability is 1000, again needs to be fragment. Getting my point? So again it needs to be fragmented, and again it is going to send to the other end. So if it is going to reassemble again, so then becomes 2000 again because of its capability, again it has to be fragmented. Okay, that means fragmentation is going to be, so chance of fragmentation will be more if I go and reassemble the packets. And again, I have already told fragmentation is a very costly process in terms of time. So if you fragment means obviously you have to reassemble at some point of time. So that's why it consumes a lot of unnecessary time, because at the intermediate router it is not at all required to reassemble, because they are not the end recipient. They are not the end recipients. If they are not the end recipients, why should I go and reassemble the packets? Because they are not interested to look into the packet. They are just the routers to route the packet, to forward the packet, to relay the packet. So they are not at all interested in seeing what is the content of the packet. So why should I go and reassemble the packets at the router end to unnecessarily waste my time as far as network processing is concerned? So that's right. So reassemble process does not happen or never happens at the router end. It only happens at the destination end. Understood? So reassemble only happens at the final destination, whereas fragmentation may happen at the source end, or it may happen at the intermediate router end. But if I want to avoid the fragmentation at the intermediate router end, then I have to take the help of discovering the path MQ. Okay, so I have to discover So the path MTU, that is called path MTU. So discovering the bottleneck MTU of the path is called as a path MTU. Path MTU discovery. That so technique or that methodology is basically called as a path MTU discovery. Okay. So if you want to avoid the fragmentation of the packets at the intermediate routers, so then you have to discover the MTU of the path. So once you got the MTU of the path, so then based on the bottleneck MTU, so then you can go on. So from the very beginning, you can go on. So fragment the packets at the originating end. So no chance of fragmentation is going to happen at the intermediate routers. This is all about the basics of fragmentation and reassembly and how it happens at the originating end and the receiving end with the help of these three fields: identification, flags, and fragmentation.